as a kind of byproduct of that. So we like oxygen because we can use it for fuel, and we don't like carbon dioxide because it's a waste product. The job of the respiratory system is to get oxygen into the body and to get rid of carbon dioxide. That's a great summary of what it does. And on two terms, we're going to do these functions. So turn on into the body, that is called ventilation, in and out. Yeah. Then in the lungs, I'm going to swap out oxygen and carbon dioxide. Whenever I'm swapping gases, I'm talking about respiration. So I need to be doing a gas exchange for something to be called respiration. So that's where I'm going to see pulmonary respiration. The word pulmonary means it's in the lungs. Oxygen and getting rid of carbon dioxide. And when it reaches the muscles, I need to do respiration again. I've got to drop off oxygen to the working muscles, and I've got to pick up carbon dioxide from those working muscles. So it's a delivery system for oxygen and a garbage collection system for carbon respiration that's occurring in the lungs. Then, how do we get the air in? So let's just start from the beginning now. Lungs were the main story, but let's follow the pathway. How does the air get into our body? Two options, nose or mouth. Pretty much what needs to go is into the next part. So it needs to go into your larynx, which we may know as your voice box. Yeah, we've heard of voice box before. That's your larynx. And that larynx is where the air will go into the body and further down into the lungs. Now, you'll notice that it goes a little bit anterior, goes to the middle of your chest. And that trachea, you'll notice, has these rings around it. Those rings, they've got little muscles between them, and they're also supported by cartilage. Now, the great thing about that is it's never going to collapse on itself because of that cartilage. Yeah, if you think about like a tube and it was really flimsy, like a straw, you know, like a straw, you could just pinch it and then nothing's going to go through there. That's terrible. You can't have that for an air pipe. So what you've got, but then it splits again and again and again and again and again. So by the time we get to the ends of the splits, we have so many millions, like 8 million is the number we use. But honestly, it can vary from that, it could be even more or less. But that is what we're saying. So it goes 2, then multiplies, then multiplies, then multiplies. But at the end, it's still just a tube. Every little air-filled sac, they're described as, is infused with a heavy blood supply. Every single leaf, every single alveoli is filled with blood. And it's that amount of filling and allow that large relationship between blood supply and air supply, right? So there's not separating where the gas exchange is from where it isn't, pretty key fact in there. So that's your overview on the respiratory system. You know that the main organ is your lung, respiration, and just constantly use these words in just the same context or different ones. It's just a mishmash. But what we want to do is get these definitions down there. Ventilation is our first topic. Ventilation is getting air. The other word on there that's pretty important is the word inverse. Inverse means if pressure goes up, volume goes down. And if pressure goes down, so...
Where's the sound coming from?
Gases moving in and out of the body because we're changing the shape of the lungs. That is what the diaphragm can do. So how do we breathe in and how do we breathe out? This is inhale and we'll go out. This is the rule of Boyle's law and how we breathe. So that is how we can control our breathing. There you go. Now, honestly, that's still like on the cusp of like the anatomy side of things, curve, but still pretty linear response, pretty straight. Okay, that's the rule. Up to 75%, we've got that pattern. Now, what happens at 75%? We are high on carbon dioxide. So that is your urge to breathe. I just thought you might find this interesting. So this is obvious. And one of the outcomes of that is blood flows. So it's kind of like a cheat method, but it works really well. The reason it's not that accurate is we're very bad at taking time and making measurements compared to something electrical. So it flow freely, and then we'll take the cuff off. Okay, so block it, slowly release it, see what happens. And we're going to see 4 different events happening. If we listen to blood flow when it's blocked, you know what we're going to hear? Nothing, because you can't hear something not flowing. When it begins to flow, I take the pressure down a little bit more. Oh, I can hear more flow, but the diastolic is still blocked. I take a bit more off, and more off, and more off, and eventually the artery is open when the heart is relaxed and contracted. So important to know what's going on. Same story, different version. Here's my pictures. Version 1, you got an artery, you block it. There's nothing flowing through there, nothing to hear. Then you release a little bit of pressure. There'll be a little bit of blood flowing through, you'll hear it. You take a little bit more pressure off. There'll still be blood flowing through, but one part of the blood will still remain. Finally, there's no pressure left on there, the blood will free flow. So when can you hear blood flow? Or I'll put it better, when can't you hear blood flow? You can't hear blood flow when it's blocked. You can't hear blood flow if it's got no obstruction. So when can you hear blood flow? When some of it is being obstructed. There's some turbulence in the system. It's being kicked around a bit. You hear the turbulence. So what you're going to take when you take blood pressure is, you'll hear the first sound. That'll be when your systolic pressure